morning, students. So today we are going to discuss about the power system analysis topic, right? First I will introduce myself. So my name is K. Pavandan. I am working as an assistant professor in EEE department, right? So today the topic is power system analysis, and in the power system analysis we are going to discuss about the stability analysis in the power system. Okay, fine. So first we will go for the introduction of the topic. Okay, what is a power system stability? First we will discuss what is a stability, right? What is a stability? Can anyone give the answer? The stability is nothing but it is the ability to be stable, right? So how? In the sense we can say that the system, power system is normally having a stable operation where the steady state operation is going on. Whenever there is any problem occurs, problem in the sense here we can say that the disturbance. So there are lots of disturbance will be occurring in the power system. Major disturbance in the power system will be the ununiform loading. So the loading, the overloading, or is the different variations in the loading, continuous duration, that is one of the major problem in the power system. And another one is the sudden change, that is a transient disturbance, which can be a surge impedance or can be a surge loading or surge, whatever may be the things. That will be a lightning arresting, lighting problems, everything will be coming under the transient conditions, right? So whenever there is a sudden change in the system, there will be the stability of the power system will be in a problem, right? So usually when you are standing at the place, right, when something pushes you, what happens? We will be out of equilibrium, right? So that means we will be moving front and back somewhere, right? That means that we are in unstable condition, right? Again we will return back to the original position after some duration of time, right? So that is by coming back to the original position after the disturbance occurs is said to be a stability of the system, right? Similarly, in a power system also, if there is any disturbance occurs in the system, and if it is overcoming the disturbance and it comes back to the original position, original condition, then it can say that the system is stable. Right. So in the power system we cannot have a continuously a normal steady state operation. There will be a fluctuation in the operation, there will be a disturbance will be occurring in the operation, and that will be overcome. It has to be overcome, right? If it is not able to overcome, and if the system is not able to overcome this problem, or it undergoes some disturbance continuously in the sense, then the stability problem will occur there. So when there is a stability problem occurs, there are a lot of disturbance, a lot of problems will create, and totally the system will be collapsed. So that is the major reason why we go up to study about the power system stability, right? So there are different types of analysis we are having the power system stability. One is the most important is the transient analysis. So what happens in the power system? This is mainly due to the transient disturbance. Transient in the sense we can say that it is a sudden change, right? Any sudden disturbance occurs in the system, or any problems occurs in the system which is having a small duration of time, right? So we can have that transient stability of two types. Transient disturbances will be of two types. One is it can be a small type or it can be a large disturbance, right? Both will be happening in the system. So the behavior of the power system based upon the ability of the power system, well, which can act as a stable system or it can be acting as an unstable system, right? That depends upon how the system is behaving, right? So we can define the system as the property of the power system that enables it to remain in the state of operating equilibrium under a normal operating conditions and to regain an acceptable state of equilibrium after being subjected to the disturbance. So it has to regain its acceptable state of equilibrium. Then when it regains its state of equilibrium, then we can say that the system is said to be in stable condition, right? Hope you understood. And next one is a stability phenomena. What is a stability phenomena, right? As I already said, the power system stability can be broadly classified into two categories. That is a very important categories. One is the rotor angle stability, another one is the voltage stability. So both are two various broad classifications in the stability analysis, right? So first we will discuss what is the rotor angle stability and what is the voltage stability. Voltage stability is nothing but the variation or fluctuation in the voltage that takes place in the power system will be coming under the voltage stability. Whereas here the rotor angle stability is mainly deals with the variation in the delta. Delta in the sense that is nothing but the rotor angle, or we can also call it as a torque angle or power angle. The angle between the rotating reference frame and as well as the rotor, right? We'll discuss what is the rotor angle stability. So here the rotor angle stability mainly depends upon the real power imbalance. So you already know that the power, we will be having two types of power will be transmitted in the power transmission system. One is the real power, another is the reactive power, right? So the rotor angle stability will be mainly depends upon the real power flow, which is nothing but the P, which is equal to V into I cos phi, that is a voltage into current into power factor, right? And the reactive and the voltage stability mainly depends upon the reactive power, which is nothing but the VI sin phi, right? So both depends upon the different categories of powers, right? So the real power, when you are going to control the real power, we can control the rotor angle stability, or we can make the rotor angle to be stable in condition. And if you are going to control the reactive power, we can control the voltage. So either we can improve the voltage or we can reduce the voltage based upon the which categories we require. Based upon that, we can control the voltage by controlling the reactive power, right? This by here the major concept in the stability analysis, because stability analysis is a very vast topic, which is very important topic in the power system, and mostly the rotor angle stability plays a very important role. Voltage stabilities that can be majorly occurs in the distribution system, especially in the end users, where whenever the load increases, we have the fluctuation. In the house also, you will have the fluctuation of the voltage. That due to the mainly due to the increase in the load. So in the evening time and the night time, we can have the voltage fluctuations. There will be a reduced in voltage. That is a voltage instability, right? So basically, if you are having a voltage instability, we can go for the different types of devices are available. Fax devices are available, custom power devices are available, and then we can go for the stabilizers. That is we can have different availability of devices are there to control the voltage. Whereas the rotor angle stability mainly comes and deals with the source, that is the generating part, main part. So that plays a very important role in the stability analysis. Hence only the stability analysis mainly will discuss about the rotor angle stability, which plays a very important role and very important thing which has to be treated, right? So that is the one we go for the rotor angle stability, right? Okay, fine. Before going to this, I will just explain what is a rotor angle stability. So we already know that how the power is generated. The generator will have the stator, where the stator will having a three-phase system, three-phase supply, and three-phase winding, and we will have the rotor. Rotor will be like a silent pole or cylindrical pole. We have two types of rotors are that alternator, right? And the generator, what we will give, we will give the DC supply to the rotor, and we make a rotor to rotate by means of some external prime movers. The prime mover can be a turbine or a steam turbine or whatever may be, or hydro turbine, whatever may be, right? We are going to rotate the rotor in a synchronous speed. What is a synchronous speed? A synchronous speed is nothing but it's a constant speed which it has to maintain, right? Which is equal to 120 F by P, where F is the frequency of the supply and P is the number of poles, right? And now here the synchronous speed, the rotor will be made to rotate in the synchronous speed. That is the constant speed which has to be maintained to be rotated at a constant speed. When you are going to rotate the rotor in a constant speed, a flux is created in between the stator and the rotor, and that flux will be a rotating magnetic field, RMF. So, and this rotating magnetic field will cut the conductors in the stator, and each conductors are at a phase difference of 120 degree phase difference, and that flux will create another EMF in the rotor, in the stator conductor, which generates a three-phase supply. This we already studied in the machines too, so I don't want to go to repeat it. So I want to recollect what are the topics we have discussed in the we have studied in the machines, right? So this is the basic principle of an alternator. So now we are having three major things. One is the stator, and the second one is the rotating magnetic field, and third one is the rotor. So these are the three major vectors, and all the three are having alternating quantities. We can represent all the three quantities to be near vector quantities, right? Now the rotating magnetic field already as we discussed that the rotor and the rotating magnetic field both will be having at a synchronization, right? It has to be at a synchronization which should be at a speed of 1000. Usually will have the speed of 1200 RPM, right? For a 4-pole machines, right? So it has to be having a speed of 1200 RPM, but synchronous speed. We keep it as a synchronous speed, right? Now the angle between that rotating magnetic field and the rotor, in terms of a vector quantity, if you take it, that the angle representing the rotor and the rotating magnetic field will be represented as a delta, which is not as a rotor angle, right? So this rotor angle has to be maintained constant throughout the system. That means the rotor speed and the rotating magnetic field should be maintained constant. When it is having maintained constant, the angle between, because we assume that the vector is rotating continuously 360 degree, it is rotating continuously. So both the rotor as well as the rotating magnetic field as rotating simultaneously equal speed means the angle will be maintained constant. Whenever there is any change that occurs in the rotor position, or whenever there is a change occurs in the rotating magnetic field, the angle will be increasing. So that is a problem occurs in the rotor angle stability. Suppose here we can see that we have two machines are there. I assume that there are two systems are running parallelly, which is tied by a wire, right, or any thread or anything, right? So we assume that the first one is said to be will be a stator and the second one is the rotor, right? Now we are this distance between the stator and rotor we consider to be a delta. We assume it to be delta. Now we are increasing the load in the rotor side. So when you are going to increase the load in the rotor side, what will happen? Load in the rotor side means actually we are taking the supply from the stator. When you are going to supply, you are going to take the real power from the stator. We cannot immediately, it cannot take the power. Actually we are giving a steam for the running. Suppose assume that the rotor is running at 1200 rpm or 50, here it is mentioned as 50 kilometers per hour, whatever may be, right? You assume that it is moving at 50 kilometers per hour, right? We are giving an acceleration for 50 kilometers per hour, right? Now we are increasing the load in the rotor. So what happens? The load will be decreasing. The speed of the rotor will be decreasing because we are increasing the load. When it decreases, but what as per the theoretical analysis, the alternator should have a constant speed which should run at a synchronous speed. So suppose assume that as the load in the rotor is increased and the speed of the rotor decreases, we want to increase, it decreases to 45 kilometers per hour. We have to increase the rotor speed. So we are giving more acceleration. When you are going to increase the acceleration, now it again comes back to the 50 kilometers per hour. But here we can see that the second diagram, the delta angle increases. And once it reaches the 50 kilometers per hour, again both will be running simultaneously. But what is the problem here is the delta is increased as well as the speed of the rotor is 50, but what is the power given to the rotor is 55. We are increased the acceleration from 50 to 55. We are giving more power to the rotor, right? Now what happens? Again we are increasing the load further to the rotor. When you are going to increase the rotor's load continuously, again what happens? Again the speed decreases. Assume that it again comes back to the 45 kilometers per hour. Now again we are increasing the acceleration. Again we are giving another 5 kilometers per hour acceleration, more acceleration we are giving. So now again the rotor comes to the original position, comes to the 50 kilometers per hour. Now we can see in the diagram delta is again increases. So in the first diagram, and we can compare the three diagrams, we can see that the delta is gradually increasing, right? Now we can see that both the machines are running at 50 kilometers per hour only, but what is the force or power given to the rotor is we are giving a 60 kilometer per hour power, right? Now assume that suddenly the load is removed from the rotors, from this second part. What happens? We are removing all the loads from the rotor side. So when you are going to remove the load, all the rotors from the rotor side, the first machine will be running at 50 kilometers per hour, whereas the second machine will be running at 150 kilometers per hour. Because we already increased the acceleration, that acceleration will be continuing. And once the speed between the two machines are changed, automatically the synchronization between the stator and rotor will be totally collapsed and it will be totally shut out. So this is the problem occurs in the rotor angle stability. So the problem here is we cannot control the load variations, because in a power system the load variation will be continuously changing. We cannot control because it is connected to the infinite bus bar. So whatever the load we connecting, it will be continuously changing at the time to time, right? So whereas this variation in the delta has to be maintained constant, right? So it has some flexibility. It can increase, the delta can increase from some flexibility values, but it has to regain to the original value of the delta once the load is removed. If there is a sudden change in the load occurs in the rotor side, then what happens? The delta will be totally cancelled. It's collapsed and the system will be totally cancelled in the problem, right? That's the thing. That is a major problem occurs in the rotor angle stability, right? So here we will have the synchronization, that is the rotor generator losses its synchronizations and fall out of the step with the rest of the system, and we capture different types of rotor angle phenomena will occurs, right? So just I give only one short time and then we will wind up this session today. So as I already said that we have the three different reference frame. One is the stator reference frame, stator synchronizing rotating reference frame, and rotor reference frame. These are the three different reference frame, and this reference frame will be rotating with respect to the rotor, right? Rotor side, right? So with this we will be stopping here this today's class, and just I conclude what are the things we have discussed today. We have discussed what is the stability and what is the power system stability, what are the different types of power system stability that is occurring, and especially we are dealing with the rotor angle stability, which plays a very important role in the alternator generating system, and the rotor angle stability mainly depends upon the real power flow and how the real power flow, how the rotor angle varies when the load increases, how the delta increases, right? Hope everyone understood the concept. If you are having any doubt, you can ask me, right? Okay, thank you.